Today's lesson talks about angular measure. Angles are measured in a variety of ways. Most people are familiar with using degrees to measure an angle. In trigonometry, radian measure is used primarily. The radian is the measure of the angle formed by rotating the radius of the circle through an arc equal in length to the radius. So if we have a circle and we look at the angle where the arc, so a part of the circle is called an arc. So if we take a look at this is an arc right here, and we're saying that this arc has the same length as the radius. Well, this angle right here that's formed by the arc, that angle is 1 radian. 1 radian. 1 radian is that. That's what 1 radian is. We also know that 1 pi radians, so what's 1 pi? Well, what's pi? Pi is 3.14. So if you have 3.14159 radians, that's exactly 180 degrees on the nose. So pi radians is equal to exactly 180 degrees. So part of what we're going to do today is we're going to learn how to take an angle that's in degrees and we're going to turn it into radians. And we're also going to take something that's in radians and we're going to turn it into degrees. So first off, example, express 60 degrees in radian measure. So how do we do this? Well, all we do is we multiply the angle by pi over 180. Now you might say, why are we multiplying by pi over 180? Well, we just found out that pi is 180. So really so pi is 180. So really we're multiplying this by 180 over 180, which really means we're multiplying this by 1 over 1, which we can do. We've done that before with things. So we're not changing this by doing this. We're just multiplying it by pi over 180. And when we do that, we're going to get 60 pi over 180. But what we're also going to do is we're then going to look at these numbers and say to ourselves, well, is there a number that goes into 60 and 180? Because we're going to try and reduce this fraction. 60. 60 goes into itself once, and it goes into 180 how many times? 3. So we end up with 1 pi over 3, which can just be written as pi over 3 radians. So 60 degrees is equal to pi over 3 radians. So that's how we take an angle in degrees and turn it into radians. Now let's go the reverse. Let's take something in radians and turn it into degrees. 3 pi over 4. Let's turn that into degrees. We said earlier that pi is equal to 180. So that means that I can take the pi, replace it with 180, and just go 3 times 180 divided by 4. And when I do that, what might I get?
54? 540 over 4. Oh, right.
540 over 4. So what's half of 540?
135.
270, and then you take half of that, and you get 135, yes. So the answer is 135 degrees. So what if we have a not so nice angle, like just like a random 26 degrees, and we want to write that in radian measure, and I say we want radian measure to 2 decimal places? What's that going to look like? Well, it's similar. You still take 26, you still multiply it by pi over 180, but now the thing is, I don't need us to write this as a fraction. So what I need you to do is just to, in your calculator, punch in 26 times pi divided by 180. What do you get?
0.453785605.
45375.
453785605.
Okay. Okay. So, and if we're going to write that to 2 decimal places, then we just have to round the second decimal place, so 0.45 radians will suffice. So here's the deal. When we are asked to write something in radians, if it talks anything about decimal places, this is okay. If it doesn't talk about decimal places, or doesn't say like approximate value, then you have to do it the first way we did it. Okay? But both ways you need to know. You need to know how to do this, which is no real different than the last way, except we're plugging in 3.1415926 blah, 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 blah for pi. That's all we're doing. And we're working it out. Now, this next example says, express 4.1 radians in degree measure to the nearest degree. So in order to do this, there's no pi to plug in 180 to. But what we can do is multiply it by 180 over pi. And again, use the pi button on your calculator to come up with an approximation. We're going to round this to the nearest degree. What do we get? 4.1 times 180 divided by pi. What do we get?
234.912696.
34 or 54?
34.
34?
Yep.
Okay, good. So 234. If we round that to the nearest whole degree, we'll be looking at 235 degrees. Right?
Yep.
Good. So that's what we get for that angle. If it's in radians and the radians don't include pi, then we multiply by 180 over pi, substituting in pi, and it'll give us the measure of the angle in degrees. When working with sectors of an angle, a ratio can be used to find an unknown arc length or a sector angle. Here's the ratio: arc length over the circumference is equal to the sector angle over 1 revolution. Now the arc length, we're going to call that x. The circumference of any circle is 2 pi r. The sector angle we're going to call theta, and 1 revolution is 2 pi, or 360 degrees. So really, this is the golden ticket, despite the fact that I cut theta off, but that's the golden ticket. That's what we're going to use to solve this question. X over 2 pi r equals theta over 2 pi. So, in a question like this, we should know 3 of these things, and or all but one thing, and trying to figure out the last thing. So we want to find x, so we don't know x. What's the radius? Well, the radius appears to be what? 8 centimeters. So it's x over 2 pi times 8 equals theta, which is what?
2.9.
2.9 over 2 pi. Now 2 pi is just 2 pi. And now we can just go ahead and work this out. And, you know, something's funny is going to happen when we try to go ahead and work this out. Because if I cross multiply and multiply these two things together, then what I'm going to be left with is I'm going to get 2 pi times x equals 2.9 times 2 pi times 8. And then if I divide by 2 pi, can someone see what's going to happen?
Oh, it's just 2.9 times 8.
Yeah, because the 2 pi's cross off. So it's just 2.9 times 8, which is 23.2. centimeters. So that is the arc length for that question. And actually, a more simplified formula comes from that. That S equals theta r. R is the radius. That's pretty clear. Theta is the sector angle, and S is the arc length. So we can get rid of those 2 pi's and just use the formula S equals theta r as well. Okay, next question, same idea. So let's go ahead and try and see if we can use S equals theta r here. We know S, it's 11.5 centimeters. We don't know theta, in fact, that's what we're trying to find, and the radius is just 6. So theta, which was measured in radians, is going to be 11.5 over 6. So that's going to be, if my arithmetic is half decent today, that should be 1.92 radians. 1.91666666666666.
Yep.
Cool. So we round that to 2 decimal places. We get 1.92 radians for the sector angle of that diagram. An angle is in standard position when its vertex is at the origin and its initial ray is on the positive x-axis. So this is our terminal arm right here. The other, yeah, we've done this before. Yeah, we have.
Oh,
So if the angle rotates counterclockwise, it's positive. If it goes clockwise, it's negative. Good. Angles that have the same terminal arm are called coterminal angles. And the smallest of the positive angles is called the principal angle. So here we have 3 coterminal angles. 45. If you go all the way around once and then go up another 45, you get 405 degrees. Or if you go in the negative direction and go clockwise, you get negative 315 degrees. Those are all coterminal angles. You get coterminal angles by adding 360 or subtracting 360 any number of times. But when we're also talking about radians, we also have to look at the idea of you can also add or subtract 2 pi any number of times. So The first one should be straightforward because it's in degrees. If you have 120 degrees and you want to come up with one positive and one negative coterminal angle, well, give me the positive one.
480.
Yes, 120 plus 360 is 480 degrees. If we subtract, what do we get for the negative one?
Negative 240.
Yes. Now, and if this didn't give us a negative answer, then we would have to keep subtracting 360 until we got a negative answer. So, but the answer here, because this guy is positive and this guy is negative, it's 480 and minus 240. Now, if somebody else said, well, what about 840 and negative 600? Sure. Because it doesn't say find the positive and negative coterminal angle. It says find one positive and one negative coterminal angle. So if you're comparing your answers in the book or with a buddy, you may not get the exact same numbers, and that's quite all right. The next question is a little bit more fun because now we're using radians. So, 2 pi over 3. We can add 2 pi to this. Cool. That's going to give us a coterminal angle. So 2 pi over 3 plus 2 pi. So what do we got to do?
Substitute 180 for pi.
We got to get common denominator. So 2 pi over 3 can stay as 2 pi over 3. And in order to make that a 3, what has to go on top?
6.
6 pi. 2 pi plus 6 pi, 8 pi over 3. There's your positive coterminal angle.
Right.
And do you do the same thing, but you just flip the sign?
We'll do the same thing except subtract for the negative coterminal angle. So this is when I'm just going to go ahead and cheat. Sorry.
Alright.
And I'm just going to erase a couple things. I'll erase this. I'll erase this. I'll erase this. Because now we are going to be doing some subtracting instead. So that's going to be subtracting. So what do we get for an answer then if we're going to subtract these things instead of add them?
Negative 4 pi.
Negative 4 pi over 3. And that'll be the negative coterminal angle for 2 pi over 3.